Hello everyone, good afternoon. I am Nikunj, your physics faculty from QNI, and I welcome you all to the QNI class. How are you all?
We are fine, sir.
Very good. So today we're starting the new chapter which is friction. Yes or no?
Yes, sir.
Okay. So anyone having any doubt in the last chapter, that is force and pressure?
No, sir.
No doubt? Okay. So before starting the lecture, that is of friction, first we will see what are the prerequisites. So first we are requiring a knowledge of force. Okay. So I hope force is clear to everyone that what is force, what are the types of forces, what is force, is everything clear to you? Contact, non-contact, yes or no? Is this clear to everyone? Okay. So if we talk about the weightage, so from this chapter, approximately 7 to 8 marks question asked. Okay. Now what we're going to study today. So first we will see what is friction. Okay. Force of friction, what are the causes of friction, and what is the spring balance. Okay. So these are the topics we're going to cover, and at last we will see the types of friction. Okay. Clear? Yes or no? Okay. Now we'll start with the topic friction. Okay, first tell me what is friction? Friction is contact or non-contact force? Friction is
Contact.
contact. That means when two surfaces are in contact, their force act is called friction. When two bodies are moving with respect to each other. Yes or no? For example, if you see here the tire, so there's a contact between tire and the road. Yes or no? Now, what will happen when we stop pedaling, when we switch off the engine of the car or bike or scooter? So they will stop. Yes or no? After traveling some distance, they will stop. Yes or no? Tell me.
Yes, sir.
Okay. So here you can see that if someone is bicycle, okay. Now, when we stop pedaling a bicycle, sorry, when we stop pedaling a bicycle, it gradually slows down and finally comes to stop. Okay. Yes or no? Okay. Friction will act upon it. Very good. Now friction is acting, that means opposite to the direction of motion. Here, if the cycle is going towards left, that means there is a friction force between the tire and the road, between the tire and the road, and this friction force is acting opposite to the direction of motion. Yes or no? That means there is a force which is opposing the motion, and that force we call friction force. That force we called friction force. Okay. Suppose when you kick a ball, okay, so after some distance it will stop. Yes or no? So that means no force appear to be acting on the ball, yet the speed gradually decreases and it comes to rest after some time. Why? There is no force is acting, no force appears to be acting. Why? Because
The
there
friction.
is friction. Yes, some force is acting which is opposing the motion of this ball, which is opposing the motion of this ball. Yes or no? So
Yes, sir.
that means friction is acting opposite to the direction of motion. Okay, you can see here the force responsible for changing the state of motion of ball is force of friction. Yes or no? When you kick a ball, this ball comes into motion, but after traveling some distance, it will comes to rest. Why? Because there is a force which is acting opposite to the direction of motion, which is we call force of friction. And there is a contact between the ball and the surface. Every time there is a contact between the ball and the surface. Yes or no? Is this clear?
Yes, sir.
Okay, very good. So we know that friction force is a type of contact force. Okay. So whenever whenever an object moves or tends to move over the surface of another object, there is a force acting between the two surfaces in contact. We know, yes or no, that whenever one body is trying to move on another body. So there is a contact between the two surfaces of the object. Yes or no? Now, what will happen when one body is sliding or moving on the another body? So there is a contact between the surfaces of one body and second body. And after some time, you will see that that first body, or you can say the body which is in motion, that will come to rest itself. Okay, when you stop giving force, when you stop giving energy. Okay, so here you can see you apply a force on this box, so there's a displacement towards right side. Now if this block stops after some time, that means if my motion is towards right, that means there is a force acting towards left, yes or no, which is opposing the motion, and we call that force is a force of friction. Okay, so the force of friction always acts on all the moving objects, and its direction is always opposite to the direction of motion. Its direction is always opposite to the direction of motion. Are we clear till now, or anyone having any doubt?
Yes, sir.
Okay, clear. Now again we see a activity. Suppose we have an inclined plane, and suppose there is a toy car. Okay, now when we release this car, what will happen? It will travel some distance, and let's say it will come to rest after traveling this distance. Okay, so due to the force of friction of the wooden surface, the car comes to rest. Okay, now we will change the surface. Okay, in first we have a wooden surface. Now we'll take another surface. Suppose we place a cloth here. What we place a Here we place a cloth. Okay, so now if again we take the same toy car and release from the same height, now what will happen? Will it travel the same distance? Will it travel the same distance? No.
No,
Why?
more friction.
I'm saying initially we have wooden surface. So for wooden surface, this car is traveling, let's say this much distance. This car is traveling this much distance. Okay. Now if we change the surface, initially we have a wooden surface. Okay. Now we have a tablecloth here. So can anyone tell me by observation or by feeling that this car will travel the same distance, more distance, or less distance when we place a cloth on the table? Will travel less distance. Very good, Ishan. Why? Less. Yes. Very good. So if we place a tablecloth here, it will travel less distance. Why? Because we are changing the surface. Okay. That means force of friction is depending upon the nature of the surface. If surface is smooth, the body will travel more distance, and if the surface is rough, the body will travel less distance. So here from this observation, we can say that force of friction is depending upon the nature of the surface. Yes or no? Force of friction
Yes,
is
sir.
depending
Yes,
upon the
sir.
nature of surface. Yes, very good. Okay, so here, where do you think the car covered a greater distance? So in the first case, that is when the surface is of wood. Okay, but why this happen? So roughness of the surface in contact. Okay, we will always see that what is the surface when two objects or bodies are in contact. So in the first case, this tire is in contact with the wooden floor, and in the second case, this tire is in contact with the cloth. Okay, so here I am saying that here we can say that force of friction is depending upon the nature of the surface. Okay, so force of friction depends upon the nature of the surface in contact. Okay, this is very important. Okay, you can see by activity here also that in the first case car is traveling more distance, and in the second case car is traveling less distance. Okay, now again suppose there is a box and we try to push on the smooth surface. Okay, can anyone tell me, is there any surface which is perfectly smooth, means there is no
No.
roughness? Not possible.
No.
Okay. There is no surface possible in this universe which is perfectly smooth. Okay. If you see microscopically at the atomic level, so you will find, suppose you have taken a very smooth surface. Instead, if the surfaces are very smooth, again, there is some irregularity present between the two surfaces. Okay. Okay. We will talk about this later. Okay. So suppose we have a box and we apply a force here. So what happens here? This block comes to rest. Yes or no? Sometimes maybe happen now. Suppose there is a box placed on the floor and you apply a force to move it. So that box is not moving. This is happening now. For some value of force, that block is not moving. Yes or no?
Yes.
Suppose there's an almirah inside the room. Okay. Now you're starting applying the force on that almirah. So will that almirah move? That might move, but depending upon the value of force. That means initially when you're applying a force of less value, let's say of 5 Newton, 10 Newton, that almirah is not moving. But when you apply a force of 20 Newton, 50 Newton, that almirah starts moving. So here what is happening? Why initially for the lesser value of force that almirah is not moving, but for the greater value of force that almirah starts moving? Why this is happening?
Sir, because the force applied should be more than friction.
Yeah, because we know that force of friction is opposing the motion. Yes or no? Which is acting opposite to the direction of motion. Now, suppose if we are applying the force in the right direction, that means force of friction is acting towards the left. Yes or no? And let's say for the surfaces which is contact, that is surface of almirah and the floor, force of friction maximum can be, let's say, 10 Newton. So up to 10 Newton, that almirah will not move. But when you apply a force of 10.01 Newton, that almirah will start move. Yes or no? Means first you have to overcome the force of friction to start the motion. Yes or no? Now, how we can calculate that what is the value of force of friction to move the object? We will see here in today's class. But first understand that force of friction is depending upon the nature of surface. Second, to start the motion, we require a several amount of force to overcome the friction. Yes or no? Is this 2 point clear to everyone? Anyone having any doubt?
No, sir.
If anyone having any doubt, you can ask me. Any type of doubt. Yes, Sudipti, any doubt? Uvina, any doubt? Isabel, anyone, any doubt? Akshat, yes, Ishan. Beta, we calculate friction by the formula. Okay, we will study this in higher class, which is class 11th. That force of friction is equals to mu into n. Don't get confused if you don't understand, but I'm only just telling that how we calculate. First, we can calculate with the help of spring force, which we study in today's class. And second, there is a formula that force of friction is equals to mu into n. Okay. Now I know that no one will understand this formula. Now here mu is the coefficient of friction. Okay, just listen. If you don't understand, don't worry. Okay, this is not in your course. Now mu is the coefficient of friction which is depending upon the nature of surface. Okay, for example, if we have a wooden floor, so this car is traveling more distance. If we have a cloth surface, then this car is traveling less distance. So mu is telling the coefficient of friction, which is depending upon the nature of surface, which surface you are taking. Maybe the surface have more friction, maybe the surface providing less friction. Yes or no? So mu is telling us about the nature of surface, and n is the normal force. N is the normal force. Suppose you can see here, suppose you take a cup, okay, or you take a glass, okay. Now press it from the upper side. Okay, press it from the upper side. Now, initially, when there is no force from the upper side, so if you apply force in the horizontal direction, that glass may move. Yes or no? Suppose you're applying a force of 5 Newton, so that glass starts moving. Now you apply a force from the vertical direction, let's say in vertically downward direction. Are we clear till now? Any doubt?
No doubt, sir.
Ishan? Yes.
So, sir, you're saying that so N is a default force.
N is we call normal force, which is acting perpendicular to the surface. Which is
Okay.
acting perpendicular to the surface. Okay. So now understand. Now when you apply the force in vertically downward direction, so what will happen? Suppose initially when there is no force, so this glass starts moving only for 5 Newton force. Now you apply force from the upper side in vertically downward direction. Now maybe force required to move the block is 10 Newton. Now when you increase the force in vertically downward direction, again to move that block the force is required is more. Yes or no? That means friction force is also depending upon the normal force, which means the force which is acting perpendicular to the surface. Yes or no? I'm just giving the idea, don't get so confused, no need to go in that much deep. Okay, just remember two things, that force of friction is depending upon the nature of the surface, and the normal force means the force which is acting perpendicular to the surface. Okay, we all we all know that force of gravity is present everywhere. Yes or no? That means if there is a block, so there is a contact between the surface of the block and this floor. Yes or no? Now this block has some weight. Yes or no? This block has some weight.
Yes,
Tell
sir.
me. Yes. So this weight is acting in downward direction. Yes or no?
Yes, sir.
That means this downward direction force is pressing the force in downward direction.
Yes, sir.
So
Yes, sir.
the force of this weight of this block is nothing but the downward force which is acting perpendicular to the floor.
Yes.
Here, the weight of this block is the normal force. Okay. So more the weight, more force is required to start the motion. Yes or no?
Yes, sir.
If you increase the weight of this block, the force required is more to start the motion.
Yes, sir.
Ishan, are you
Yes, sir.
getting? Okay. So we can calculate the force of friction by the formula mu into n, where mu is the coefficient of friction depending upon the nature of the surface, and n is the normal force. Okay. If you increase the weight, you can feel that force required to start the motion is more. Okay. Now, any other doubt? Anyone? Any other doubt?
No, sir.
Okay. So till now we have studied about friction, that friction is a contact force. It is acting between the two surfaces in contact, and it is acting opposite to the direction of motion. Yes or no? And if we change the surface, so maybe for the one surface the distance covered by the body is more, maybe for the second surface distance covered by the body is less. That means we can say that friction offered from one surface may be different from the friction offered by the second surface. Yes or no? Are these things clear to you?
Yes, sir.
Forget about the formula. Are these things clear to you?
Yes, sir.
Everyone,
Yes.
Puvina, Vinappa, everyone, Isabel, are these points clear to you? Anyone having any doubt? Just show me thumbs up. Everyone, Sai, Sudipti, Anika, Akshat, everyone. Is these things clear to you, beta? That what is friction? What is the direction of friction force? That friction force is depending upon the surface. Yes or no? Okay. So if we have a smooth surface and we apply a force, still the block comes to rest. Okay. Why is that so? So when two surfaces put in contact, the irregularities, okay, this is important, the irregularities, that is ups and down. You can see this is the surface of the floor, lower one, and upper one is the surface of the block. Okay. Now, okay. Now this is at the atomic level. When you see from the microscope here at the interface where this block and floor is in contact. So when you see from the microscope, you can see there is an irregularity between these two surfaces. So because of the interlocking between the two irregularities, friction is offered by the surfaces. Okay. So what will happen? So when two surfaces put in contact, the irregularities, that is ups and downs of one surface, get somewhat interlocked with the irregularities of the other surface. Okay. Clear? No surface is perfectly smooth. Okay, there is an irregularity present everywhere between the two surface. Yes or no? And that the two surface get interlocked. So that's why initially when we are starting the motion, when we are initially pushing the almirah, that almirah is not starting in the not getting into the motion. We are requiring some amount of force to start the motion of that almirah. Yes or no? Tell me, are you understanding or not?
Yes, sir. Yes, sir.
Uvina, Isabel, Sai, Anika, Akshat. Akshat, are you in class? Akshat,
Yes, sir.
okay. Anyone, if having any doubt, you can ask me beta anytime. Okay, very good. Now, now force is applied, but that force is not able to set the body in motion. So what is the reason? What is the reason?
Because the force of friction is more.
Because the force of friction there present is more than the force applied by the body. Yes or no? Okay. So suppose again we have taken a brick here. Okay, now we want to move the brick. Okay, suppose you have a brick and we want to move the brick. So it's not happening that you just touch the brick and that brick will start move. No, you require some amount of force to start the motion of that brick. Yes or no? So that amount of force, that minimum amount of force which is required to start the motion of the brick is the force of friction. Yes or no? Once you overcome the friction, the block is set into the motion. Yes or no?
Yes.
Yes, sir.
Okay. So suppose we have a brake and we put a spring balance here. Okay. At the end of the thread which is tied on the brake. Okay. So suppose there is a reading here. Okay. Different values 0, 20, 40, 60, 80, 100 and so on. Okay. So these are the values given on the this spring balance. So here you can observe that if you apply a force of 40 Newton, still this block is not moved. Still this brick is not moved. Okay. But as you increase the force from 40 Newton, the reading of the spring balance changes, but the block does not move. Yes or no? Initially, the reading is 0, then it becomes 10, then 20, 30, 40. So till 40 Newton, this brick is not moving. Yes or no? So this rating gives the measure of the force of friction between the block and the wooden surface. Yes or no? Now when we apply a force of 40.01 Newton, will this brick move or not? Till 40 Newton, this
Yes, sir.
brick is not till 40 Newton, this brick is not moving. But when you apply a force of 40.01 Newton, this brick will move. Why? Because we know here the force of friction between the brick and the floor is 40 Newton. Means to change the state of this brick, that means initially the brick is at rest. We want that brick is come into motion. So to start the motion of the brick, we have to overcome the friction. And here the friction force given by the spring, this spring system is 40 Newton. So when you apply a force of 40.01 Newton, this brick will start moving. Yes or no?
Yes, sir.
Anyone, any doubt?
No, sir.
Very good. Okay. So at the you can say very close to 40 Newton, this brake starts moving. Okay, now what will happen when we increase the value of brake? Initially we have one brake, now we have two brakes. Okay, so again, can you say that for the force of 40 Newton, this brake will start moving?
No, sir.
Yes, sir.
Now we have two brakes. So for the same value of force, this brake will start move.
No, sir.
Now we have two brakes. No, suppose there is a Almira, okay, and in Almira there is no object is kept, okay. So you have to just overcome the weight of the Almira to push to move, yes or no? Now, if I place object of let's say 50 kg in that Almira, so now this time again the force required is of only initial one or the force required is change?
Change, sir.
Change. So here also I increase brakes from 1 to 2. So here again, will the force of friction increase or decrease?
Increase, sir.
Everyone tell me here the force
Increase.
of friction increase or decrease if we increase the value of brakes. Tell me. Increase. Very good. That means here, if we want to know the force of friction, then again we start pulling this spring balance, yes or no? Now, again, if we increase the spring balance, now this time you can see the force is required somewhere around 80 Newton. In the first case, if we have only one brake, the force required is only 40 Newton. Now we have two brakes, so the force required is 80 Newton. Yes or no?
Yes, sir.
Okay. So here the reading of the spring balance changes, but the block does not move. Why? Because of the friction. Yes or no? Now this reading gives us the measure of the force of friction between the block and the wooden surface. Yes or no? Okay. Now for the value of approximately 80 Newton, we can say this blocks will move. Okay. So please remember that force of friction depends on the two factors. First, the nature of the surface. Okay. The surface is more smooth, less smooth, it is rough, yes or no? Now again the weight of the body. Okay, if you increase the weight, the force of friction will keep on increasing, yes or no? Is this clear to everyone?
Yes,
Yes,
sir.
sir.
Okay, very good. Now we'll see something about spring balance. That what is a spring balance? So this is a spring balance, you can see here. Now a spring balance is a simple device that can be used for measuring the force acting on an object. Measuring for the force acting on an object. Okay. Now it consists of a coiled spring. Inside there is a coiled spring. Okay. Which gets stretched when a force is applied to it. Okay. There is a, you see, everyone sees the spring. Yes or no? Now the structure of this spring is somewhere coiled. Yes or no? So many coils are there. So when you apply a force, so that spring will stretch. Yes or no? So also in the spring balance consists of a coiled spring which get stretched when a force is applied to it. Okay. So there is a ring. Okay. Now stretching of the spring, that how much spring is stretched, is measured by a pointer moving on a graduated scale. Okay, here you can see there is a pointer. Okay, initially there is no reading, but as you apply the force, we know that spring will stretch, and how much amount of spring is stretched, it is, we know with the help of the reading. Okay, so there is a pointer. Here you can see there is a force is 80 Newton. Okay, so here stretching of the spring is measured by the pointer moving on a graduated scale. Okay, so if the force is said to be 1 Newton. Now what is the meaning of 1 Newton force? So the meaning of force of 1 Newton is that it produces an acceleration of 1 meter per second square in a body of mass 1 kg. Okay, suppose, okay, so suppose there is a body of mass 1 kg. When you apply a force of some, suppose there is a body of mass 1 kg, and if it is having acceleration of 1 meter per second square, that means body is having a force of 1 Newton. So now what is Newton? So Newton is nothing but the SI unit of the force. So what is the SI unit of the force? It is Newton. And what is the meaning of 1 Newton? That a force is said to be 1 Newton if produces an acceleration of 1 meter per second square in a body of mass 1 kg. So anyone having any doubt that what is spring balance?
No, sir.
Okay. So we know that force of friction is acting opposite to the direction of motion. It is a type of contact force. Now unit of friction is measured in terms of force, that is Newton. Okay, and what is 1 Newton? That if a body of mass 1 kg having an acceleration of 1 meter per second square, force of friction depending upon the two factors. First, the nature of the surface, and second, that what is the weight of the body. Yes or no? If you keep on increasing the weight, force of friction starts increasing. Clear?
Yes,
Yes
sir.
or no? Okay, very good.
Yes.
Now we'll see what are the factors affecting friction. Okay, so first we know that nature of the two surfaces in contact. Second, force pressing the two surfaces together. First one is the nature of the two surfaces in contact, and second one is the force pressing the two surfaces together. Is these 2 points clear to everyone?
Yes, sir.
Anyone having any doubt in
Sir,
this two?
can you explain the second point, sir?
Force pressing the two surfaces together. Yes, but I already told you now. Suppose I have a brick. Okay, okay, understand. Suppose I have a brick. Now I am applying a force of initially 1 Newton, and this brick starts moving. Okay, this brick starts moving. Now if I increase the number of brick, so can you tell me that for the same amount of force, will this brick move?
No, sir.
Why?
More mass.
More mass. That means, can we say now initially this brick is pressing this surface with some value? Yes or no? With some force. Now if I increase the value of brick, now these two bricks now again pressing this surface by some another value.
Yes, sir.
Yes or no? Now initially I'm using this surface. Now if I increase the roughness of the surface, will the force of friction will change?
Yes.
Yes or no?
Yes, sir.
That's why we are saying that's on what factors friction are depending. First, the nature of the two surfaces in contact, and the second, the force pressing the two surfaces together. Okay? Yes or no? Any doubt in these two factors? Anyone having any doubt? Okay, very good. Now frictions are of two type. First one is static. Okay, now what do you mean by static friction? So as we already know that initially if there is a almirah or a box and we start applying the force, so initially it might possible that that almirah or box is not moving. But if also the almirah or box is not moving, is there a force acting between the two surfaces which is opposing the motion? Yes or no? Initially, suppose there is a almirah and you're applying a force of 10 Newton, We know that for Almira, suppose the force required to start the motion is 50 Newton. So initially, if you are applying the force of 10 Newton, will the Almira move?
No.
No, sir.
No. For 20, for 30, for 40? No. Yes or no? But can we say for different values of force, that is for 20, 30, 40, there is a force which is acting opposite to the applied force, which is opposing the motion? That is friction force, yes or no?
Yes, sir.
And that friction force is called static friction. That friction force is called static friction. So now can anyone tell me what is static friction? What is static friction? Can anyone tell me?
So what's the difference, sir?
Between what?
Like normal friction and like static friction.
No, there are two types of friction, static and kinetic. Friction are of two types, static and kinetic.
Friction is
Now,
of two types. Okay.
yeah, friction itself two types, static and kinetic. Now, what's the difference? Okay, suppose, let's understand. Suppose there is a box. Okay, box of 50 kg. Okay, lying on a surface. Now, to start the motion for this box, suppose a requirement of force is 50 Newton. How much force is required? 50 Newton. So if I'm applying a force of 10 Newton, will this block move or not?
No, sir.
No. Now I'm applying the
Sir.
force. I'm applying a force towards the right side. Can you tell me, is there any force which is acting or which is opposing this force?
Yes, sir.
Which force?
Friction.
Force of friction, which is acting between the two surfaces, that is of block and the floor. Yes or no?
Yes, sir.
Very good. So now this block is not moving. So if you're applying a force and the body is not moving, so the friction acts is called static friction. Now,
Yes.
if you apply force of 51 Newton, what will happen? This block will start moving. Now, again, the friction is acting, yes or no, between the two surfaces. Now the friction is called kinetic friction.
Okay, sir.
Now you get
Yes,
that what
sir.
is static and kinetic friction.
Yes, sir.
Ishan,
Yes, sir.
now is this clear to you that what is static friction, what is kinetic friction?
Yes, sir.
Um,
Okay, so let's say this is the direction of the force towards left side. Okay, we know that force of friction is acting opposite to the direction of force. Okay, so here what do we find? That the force is not sufficient to overcome the friction. Okay, if the block is not moving, that means force is not sufficient to overcome the friction. Now, why does this happen? So,
Static force.
yeah, because of the static friction. Because of the static friction. Now, this block strength remains at rest. That means when external force acts on the box, the force of friction acting is known as static friction if the body is not moving. Clear?
yes.
Yes or no?
Yes, sir.
Okay. Now,
Sir.
in the next,
Sir.
yes, Akshat, any doubt?
Yes. No, sir.
Okay. Now, everyone, from here we will start from the next class that what is kinetic friction, how to reduce the friction, how to increase the friction. Okay. Now, there's a homework for you, everyone. Please solve at least 20 questions from the previous chapter. For now, please don't attempt any question from this chapter, which is friction. Attempt question from the force and pressure. And if you face any problem, any doubt, we will solve this we will discuss in the next class. Okay. Now today there is no evening class today for science. and everyone please join the doubt class from 6 to 7. Okay, everyone is getting or not that all everyone have to join class from 6 to 7.
Yes, sir.
Okay, that is for practice session. Come in that practice session. Okay, and from home you will solve at least 20 questions from the previous chapter. Okay, yes or
Okay,
no?
Okay, sir.
Yes, sir.
Okay, very good. So I hope you enjoyed today's session. You have learned something new. So first we conclude today's lecture that what is friction? We know that friction is the force which is opposing the motion, and causes of friction, that is the nature of the surface, and the by what amount of force the bodies are pressing each other. Okay, then we know what is the spring balance, and types of friction are two, that is static and kinetic. Okay, so in the next class we will see again that friction are necessary evil. Okay, yeah, and we'll see how to increase or reduce the friction, and we will see what is kinetic friction also. Okay, so all these things we will discuss in the next class. So next class is very important. Okay, so thank you everyone. We will meet in the next class. Bye bye. Take care.